Hello children, welcome to AIMS India's online classes. In today's video, from physics subject, force and laws of motion topic we are going to continue. So let's discuss some problems children. So these are the previous Olympiad questions asked from this chapter. So these questions we can find in different Olympiad exams. So let's start with first question. So an unbalanced force acts on a body. What happens to the body? So then what happens to the body? If unbalanced force acts on a body, what happens to the body? That is the question. Option A, the body remains at rest. Option B, the body must move with uniform velocity. Option C, the body is accelerated. Option D, the body moves along a circle. So whenever unbalanced force acts on a body, unbalanced force means suppose we have a body here. From one end, if we apply 10 newtons of force in right direction, from other side, if we apply 20 newton force towards left direction, so overall force acting on the body will be, if this direction is taken as positive, this direction will be negative. So plus 10, minus 10 newtons plus 20 newtons. If we add the forces, the resultant will be 10 newtons. The resultant force acting on the block will be 10 newtons. 10 newtons. This is called net force. So two forces acting on the block, but they are not balanced. If the net force is 0, then we call them as balancing forces. But here the net force is not 0, it is having some magnitude. So these are considered as unbalanced forces. So when unbalanced force acts on the body, so from this side towards left, force is more. So that's why overall net force 10 newtons. The body will be acting towards left direction with 10 newtons net force. So because of net force, the body cannot remain at rest. Option A wrong. Must move with uniform velocity wrong. We cannot tell. Whether it will move with the uniform velocity or not, because it depends on the friction offered by the floor. But previously it was under rest, but now its velocity is increasing, so the body accelerated. It's correct. The body moves along a circle, that also we cannot clearly tell whether it is moving in circle or straight line. Only out of 4 options, 1 option is definite, that is whenever unbalanced force acts on a body, the body should be accelerated. So option C is correct. Option C is correct. Next, number 2, second question. If no force acts on a body, what will happen to it? If no force acts on a body, what will happen to it? So if no force acts on a body, the body at rest will remain at rest. If it is at rest, it will continue to be at rest position, or already if it is moving, then it will continue to move with the same velocity. It will try to continue its motion. It will try to continue its state of rest, or it will try to continue its state of motion when there is no force acts on the body. If force acts on the body, then the body which is under rest will start moving, or the body which is in motion, if force applied in this direction, velocity will increase. If force applied in opposite direction to the motion, velocity will decrease. But without force, the motion of the body will continue. continue in straight line. So it does not change its shape, wrong. It continues to move, but with the less speed, we cannot tell exactly. It changes its direction, exactly we cannot tell. It can either remain at rest or continue to move in straight line. This is correct. Based upon state of the body, if it is at rest, continues to be at rest. If it is in motion, continue to be in motion in the same straight line. So option D is correct. Option D is correct. Next, third. How much mass approximately of a body one can hold when a force of 1 Newton is applied on it? So how much mass approximately of a body one can hold when a force of 1 Newton is applied on it? So here we have the formula for force. According to Newton's second law of motion, force is defined as ma. Force equal to ma, where m is the mass, a is the acceleration. A is the acceleration. So here how much mass approximately a body, approximately of a body one can hold when a force of 1 Newton acts on it. Acts on it means when we are holding any body, then the body will be under the influence of gravitational force or indirectly acceleration due to gravity. So here this a value we have to take it as z. We have to take it as z. So then or indirectly it is nothing but weight. How much mass approximately of your body one can hold means indirectly it is nothing but weight. Indirectly it is nothing but weight. So F equal to mz formula or weight equal to W equals to mz formula we can apply here. So where mass so here force 1 Newton they have given. So here weight, indirectly for holding we will make use of concept weight. Here force is nothing but weight of the body. Weight they have given as 1 Newton. Mass we have to find out. Z value equal to acceleration due to gravity 9.8. So force equal to m into 9.8. But 1 kilogram is about 9.8 newtons. 9.8 newtons. So here m value. So here actually one minute here. Here force they have given 1 Newton. 1 Newton equal to m into 9.8. M into 9.8. Where mass equal to 1 Newton by, so 9.8. 1 Newton by 9.8. So but here 9.8 meter per second square we have. 9.8 meter per second square. Again, why they have taken grams here? Here children, 1 Newton means 1 Newton. Newton is the special name for the unit kg meter per second square by 9.8 meter per second square. Meter per second square cancel. 1 kg by 9.8, where 1 kg can be written as 1000 grams by 9.8. 1000 grams by 9.8. So if we approximately this 9.8, if we take it as 10, then approximately we can take it as 1000 by 10 grams, because 1 kg we have converted into grams. So 10 hundreds are 1000. So answer will be 100 grams. So when a force of 1 Newton is applied, means indirectly one can hold a mass of 100 grams. A mass of, if we hold a mass of 100 grams, then the force acting on that mass will be 1 Newton, or weight of that body will be 1 Newton. So option B is correct. Next one, fourth question. So when a bus suddenly starts, the passengers are pushed backward. Which of the following laws is illustrated in this example? When the bus suddenly starts, means the bus is under rest position. The passengers in the bus will be under rest position before the starting of the bus. Before the starting of bus, they will be under rest position. When bus suddenly starts, after the starting of bus, so the passenger in the bus slightly they are pushed backward. Why? What is the reason? Means the upper part of the body continues to move along with the bus in the front direction, but the lower part of the body of the passenger, which is in contact with the bus, it comes into motion along with the bus. But due to inertia of rest property, here, sorry children, 1 minute. When the bus suddenly starts moving, the lower part of the body is in contact with the bus body. So along with the bus, it starts moving forward. But whereas the upper part of the body, which is not in contact with the body of the bus, still continues to be at rest position due to inertia property, due to inertia of rest. So that's why the upper part of the body fall backwards, or the passengers fall backwards. So this law of inertia, this concept is explained in law of inertia, which is also called as Newton's first law. So option A is the correct answer. Next, fifth question. Consider a porter standing on a platform with a suitcase which presses his head with a force of 200 newtons. One porter is carrying one suitcase. Which is pressing his head with a force of 200 newtons. If this force, the suitcase pressing the head of the porter, is taken as action, from where is the reaction force exerted and to where is it directed? So the action reaction always acts in pair and opposite to each other and on different bodies. Here the surfaces in contact are, one is the suitcase and other one is the head of the porter. If the suitcase presses the head of the porter, if that is taken as action, then the head of the porter presses the suitcase in the opposite direction towards upwards. That will be considered as reaction. So the head on the suitcase, the force shown by the head on the suitcase is known as reaction force. And where is it directed? Means towards upwards. So why it is so means it is because of Newton's third law, which we have already discussed in our concept. According to Newton's third law of motion, so for every action there is equal and opposite reaction. So the head of porter also exerts a force of 200 newtons, same like action, on the suitcase, which is known as reaction force. So always the action force and the reaction force acts on two different parties. Action force will be acting on the head. Reaction force will be acting on the suitcase. This is 200 newtons downwards. This is 200 newtons upwards. This is plus 200 newtons. This is minus 200 newtons. But they never cancel with each other. Because why they never cancel with each other means they are acting on two different bodies. They are acting on two different bodies. If same forces, if they act on one body with same magnitude in opposite direction, then total net force will be 0. Here in this case, the net force is not 0. Why means in action reaction pair, the force will be acting on two different objects. Two different objects. So option A is correct. Next one. A force of a given magnitude acts on a body. On what factors does the acceleration of the body depend? So a force of given magnitude means which is having some value or product of a numerical and unit is called magnitude, denoted by the symbol P, without any direction. So some kind of force is acting on a body. Means because of the force, the velocity of the body will increase and it will be accelerated. The body will be accelerated. Now the question is, on what factors does the acceleration of the body will depend? We have the formula for force, which is equal to F equal to ma. The force can be calculated with the help of this formula, F equal to ma formula. Now, if you want to find out the quantities on which acceleration depends, we have to make A as the subject. This formula to be changed as the formula in which A is the subject, or A equal to force by m. This m will come down. This m will come down. So acceleration is directly proportional to force. Acceleration inversely proportional, directly proportional to reciprocal of mass, or we can call it as directly proportional to reciprocal of mass. As we have 1 by here, we can pronounce it as inversely proportional to mass without taking 1 by. Direct, if you want to tell the relation between acceleration and mass, we can tell that acceleration is inversely proportional to mass, directly proportional to force. Density of the body, wrong. Volume of the body, wrong. Mass of the body, correct. Shape of the body, wrong. Acceleration acts on which quantities means, according to options, C option is the correct. According to option, C option is the correct. And how it is related to mass is, it is inversely proportional to mass. Means if the mass is more, acceleration will be less. If the mass is less, acceleration will be more. Like that. Like that, acceleration and mass are related. Next. 7th question. What does the principle of conservation of linear momentum state? So in the word itself, we are having the meaning of this principle. So conservation means the linear momentum will be conserved. Linear momentum will be conserved, or linear momentum will be protected. Linear momentum will be protected means neither created nor destroyed. Neither created nor destroyed. But it simply changes from one body to another body. So, but total momentum will always be conserved. When, if there is no external force acting on the system, if there is no external force acting on the system, the total momentum of the system remains constant or remains conserved, remains protected. So, okay. The linear momentum of a system cannot be changed, wrong, because complete definition they have not given. Linear momentum of a system cannot remain constant, wrong. Linear momentum of a system can be changed, wrong. Linear momentum of system can be changed only if external forces act on it. So indirectly, this is giving the meaning of this. If external forces acts on it, linear momentum will change. If no external force, linear momentum cannot be changed. So indirectly, D option is the correct answer. So 8th question, children. On which of the following do action-reaction forces act upon? So just now we have discussed, children, in the case of a suitcase carried by a porter, action acts on the head, reaction force act on the suitcase. Means both acts on different bodies. Both acts on different bodies. That's why they won't cancel with each other. So action and reaction forces acts on different bodies. They are equal in magnitude but opposite in direction. They will be having same nature. Their nature is different. Sorry, their nature is same but act on different bodies in different directions. So option B is correct. Different bodies is correct. Same body, wrong. Different lines, wrong. In same direction, wrong. Option B is correct. Next, a force produces an acceleration of 5.0 centimeter per second square. When it acts on a body of mass 20 grams, find the force acting on the body. We have the formula of force F equal to ma, where mass is 20 grams. They have given here already in the question, and A is 5 centimeter per second square. Both the units are in CGS system, so no need to change them. We will get the force. We will get the value of force in CGS system. So 20 into 5. If we multiply, it will become 100. As the units are in CGS system, force also to be taken in CGS system. 100 dynes. Actually, gram centimeter per second square. We will get this unit, but this unit is having a special name, dyne. If you want to change this dynes into newtons, the value, whatever magnitude we have got, it should be multiplied with 10 power minus 5 newtons to change into newtons. One dyne equal to 10 power minus 5 newtons. Let's multiply with 10 power minus 5 newtons. Then 100 into 10 power minus 5. 100 can be written as 10 square. 10 square into 10 power minus 5. As the bases are same, we can add the powers. 2 minus 5 equal to minus 3. So 10 power minus 3 newtons, or 1 into 10 power minus 3 newtons. So A option is correct. So children, that's all for today, children. So remaining we can learn in our next video. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website, children, www.aimstudio.in, for information regarding previous online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.